All right, here to finish up the August 2016 exam, starting at number 33. Let's see, we've got a transformations problem. Let's see. Determine and state the location. Oh, okay. So they're telling us where C prime lands. So let's go ahead and graph 8, -3. Okay, so there goes C prime. Now, the center of rotation is point A. So here's what you can do. Um, what it looks like to me is if from C to A, that slope is undefined. 1, 2, 3, 4, 5, 6. We could say it's up 6 across 0. That's undefined. Vertical line. And C prime to A, that slope is going to probably be 0, 6. 1, 2, 3, 4, 5, 6. It is. Okay, so it's 0, 6, and that is 0. Okay. Now, these two, this is a special case where you don't need negative reciprocals here. What it is when you have a vertical line and a horizontal line, that's going to get you a perpendicular line. So that angle right there, angle A is a right angle. So the rotation angle is 90 degrees. Okay. Now, we go counterclockwise with rotations unless specified otherwise. So that is a 90-degree rotation. All right, centered at point A. So now we just have to do that with B. Okay, so B to A, now this is going to be a little different. Okay, B to A. Pause it. So B to A. Okay, you've got a slope of. So this is just the way I do rotations. There's a lot of other ways, but this is how I do them. B to A has a slope that is negative. As you move left to right, this segment is moving down. So it's a negative slope. The rise is 5, the run is 4. So if I want to make a 90-degree rotation, B prime to A would have to have a slope that is the negative reciprocal, 4/5. Okay, negative reciprocal slope. Gives us perpendicular, and perpendicular gives us right angles. And we know, of course, right angles are 90 degrees. So there's a lot going on here. Okay, so right angle, we want to do that. Now, so what we're going to do is we're going to start at A, and we're going to apply a slope of 4/5. So you can go up 4, right 5. That could be one location for B prime. Let's see. That is in the same direction, so that looks good to me. Of course, if that wasn't going to work, we could have gone this way, down 4, left 5. But this looks good. 1, 2, 3, 4, 5, 6, 7. Looks like 7, 1 for the location of B prime. Let me double check that. Yep, that's what I have the last time I did it. All right, now there is, the next portion of this is the triangle DEF, congruent to triangle A prime, B prime, C prime. All right, if we connected these, right? Okay, I see it. It looks like we could perform a line reflection that would map this triangle onto that one. Okay, so it's perpendicular in congruent distances. You should be checking this. Yeah, so, all right, here's what we could say. If we reflect triangle A prime, B prime, C prime over the line x equals -1. That's what this line is. Okay. It would map triangle A prime, B prime, C prime onto triangle. Now make sure we get the lettering correctly. So A goes to D, B goes to E, and C goes to F. So that's good. Um, since a rigid motion transformation okay, we'll quickly explain what that is. Since a rigid motion transformation, okay, line reflection, keeps image and pre-image congruent, that's what rigid motion transformation means. It's going to keep it congruent. Um, so since a rigid motion transformation could be used to map triangle A prime, B prime, C prime onto triangle DEF, triangles must be congruent. Oh, first I gotta say yes. Yeah, let's make sure we answer the question. All right, so that'll be good enough. They kind of want to see this concept in there explained a little bit. There's other ways to do this problem. You could go ahead and, you could calculate the lengths, use a side-side-side proof. But the intent, I believe, is for something like this. So, like I said, plenty of other ways to do it, though. If your teacher does it a way different way, it's fine. Just go ahead and use that. Okay, so this looks like a trig problem. Inverse. Okay, so yeah, we have to find angle measures. So here's what I like to do with triangles where they've got a couple of different situations here. All right, let's call this y degrees. That's 12 and 75. Let's go get y. And what we'll then do is, let's see, add these together. That's 72. Then we'll get x degrees, and then we can subtract to get theta. That's what I think we'll do. All right, so it's going to be a couple of trig problems. All right, this is the hypotenuse. That's not involved. Compared to the y angle, that's opposite and adjacent. So let's go with, there's your acronym to figure out which trig function to use. Opposite, adjacent, right? That's got the O and the A. So we're going to use tangent. So tangent of some unknown angle will define, this ratio, 12 over 75. Now, what I personally like to do with this is change that to a decimal. You don't have to. That just seems to work better. It makes a little more sense for my students. So I try to do that. It's 0.16 exactly. There's no rounding there. And what I do is I don't like to just all of a sudden it appears that there's tangent inverse. There's a reason. We want to lose the tangent function. So to do that, we have to perform the inverse operation, okay? So hopefully we're talking about inverse operations in your classes. So we're going to apply the inverse operation to tangent. That is tan to the negative first, or arctan. Now I'm going to perform that tangent inverse to both sides. So I'm going to rewrite this. Okay, that's going to stay. I'm going to perform tangent inverse in front of it. Tangent inverse of that 0.16. Now the idea is, remember this says equals. You want to balance. Well, I did the same thing to both sides. I applied tangent inverse. Okay. Tangent inverse of tan, those two functions are inverses. So they're going to make each other disappear, knock each other out, whatever you want to say. So y is going to be whatever tangent inverse of 0.16 is. So you type that in, and you get 9.09028, and so forth. Okay? Now we're going to do that same process to calculate x. All right? So pretty much the same thing. Tangent of x degrees 72 over 75. Same thing, opposite over adjacent. Again, we're going to do, yeah, hold off for a second. 72 divided by 75 is 0.96. Apply the inverse operation to tangent to get rid of tan. All right, same thing to both sides, so it's balanced. And we get x degrees is 43.83 degrees. All right, so now theta is going to be whatever 43.83 minus that 9.09. Now it says nearest tenth of a degree. Okay, so I get the closest is 34.7 degrees. Okay, and that's what we wanted. All right. Oh boy, this is one of the prove a theorem problems. Not easy at all. Okay. The best way to do this that I know of is to draw in these auxiliary segments. I'm actually going to call them that. Now, if you see this, what we have is angle C and angle A are congruent because they're inscribed angles that open up to the same arc. And then, of course, I'll use the vertical angles. And I've got similar triangles. So this is just scrap work for a second here, just to help me keep track of things. Let's go BCE. That's going to be similar. Make sure we match them up correctly. So that looks like DAE here. And that's going to be by the angle-angle similarity postulate. All right. So that's what we want to go through. And let's see. From this, AE is involved, right? Let's make sure. All right. So what's AE's counterpart if we write it this way? It's going to be CE. All right. And it looks like ED and EB. AE. Okay, we got to go up top here. So that's going to be ED up there, right? Because if AE is on this triangle, we got to be consistent, put ED, which is up top, right there, on the same triangle. Now, what is ED's corresponding segment? Looks like EB, right? First and third letter, or sorry, third, first letter, third, first letter. So EB. Now, if we cross multiply AE, that's perfect. Yeah, that's what we want right there. Okay, so what I'm doing right here, this is all really just scrap work. Whoops. This is scrap work. I am making sure that I can get the prove, right, that I want. So I'm kind of setting up angle-angle similarity. That's what I'm going for. I'm going to use this. Corresponding sides of similar triangles are proportional. And then I'm going to cross multiply. So that's what our kind of, you got to, for these proofs, you kind of have to look at the end result and then work backwards, you know, that type of thing. So that's what I'm doing. All right, so let's start off. One of the first things I did was I drew in auxiliary lines, BC, segments, I should say, auxiliary segments, BC and DA are drawn. And that is what we mean by auxiliary segments is they're drawn in to help the proof. To help proof move along. So you got to kind of do this. You can just draw those in, okay? I'm not making any claims about them. We're not saying that they're congruent or anything like that. We just drew them, okay? You know, you can connect 2 points with a segment, and I'm not making any other claims other than that it's a segment. Now, from here, I'm going to say that angle C is congruent to angle A because they are inscribed angles that open up or that intercept the same arc. That's arc BD. Okay, so when that happens, when you have inscribed angles that intercept the same arc. They should be, they are congruent. All right, a little more space here. Now we're going to go to the vertical angles. We could use B and D for the same reason, but I'm going to just use vertical angles. So angle BEC is congruent to angle DEA by vertical angles are congruent, or vertical angles theorem, whatever your teacher prefers. Okay. Now the triangles are similar. Now I'm just going to basically copy my scrap work up here. Triangle BCE is, whoops, I almost said congruent. It is only similar, so let's not say congruent. So similar to triangle DAE by the angle, well, yeah, angle, triangle similarity postulate. And now I'm going to get corresponding sides. Oops. Use this same one that's up here. That's why we did that scrap work. What does that say? ED? Yeah. Oops. ED. And that's by corresponding sides of similar triangles are proportional. Now, number 6, we're going to get AE times EB equal to CE times ED. Now, we're going to say cross multiply, but that's kind of loose. You know, the cross products of a proportion are equal is probably better. Okay, so I'll just write both. Cross multiply will be enough. I hope, you know, that my students can get that. Really, it should be cross products in a proportion are equal. It's a little bit more mathematically sound. All right, and just making sure we did the, yeah, we did actually complete what we set out to, so that's great. All right, next problem is going to be pretty involved. We've got a volume with a density, okay, and a cost. Great. Okay, so we got a lot going on here. All right, one of the first things is we have a diameter of 8.3. That means the radius is 4.15. And then that's centimeters. We've got to be careful. Hopefully, if we pay attention to units of measure carefully, we won't make any, you know, big mistakes there. And usually, you know, the units of measure will help us know what to do a little better as well. So let's pay attention to that. What we have is we have a hemisphere and a cone. We're going to fill that up with shaved ice. All right, so let's figure out how much volume there is. Okay, then we'll figure out the kilograms, and then we'll figure out the cost. So volume first. All right, so let's go with volume of a cone. That's 1/3 pi r squared h. Don't memorize that, just look it up. It's fine. There's a reference sheet for a reason. And then there's a hemisphere, but I'm going to get the full sphere and then just remember to cut it in half, hopefully. And then that's 4/3 pi r cubed. All right, so the cone first. 1/3 pi 4.15 squared. Be careful. A few of my students missed the squared there. There's a lot going on. So I can see why. Okay, so first I got the volume of the cone. Go ahead and just let the calculator do all that. 183.961. Okay. Volume of the sphere. 4/3 times pi times 4.15 cubed. Again, be careful there. Same thing. All right. So I get 299.387. Whoops. 299.387. Okay. Now we're going to do the half sphere. So we're going to do half of that. Okay, so that's going to get us 149.693. All right. So the volume of the shaved ice, we'll call it, right? The volume of the whole thing would be these two added together. So the volume of the ice that we need, that is going to be, where is that? 333.654. And that's centimeters cubed. All right, so that's the first goal. That's going to probably get you 2, maybe 3 points right there. Um, all right, let's convert that to a cost per cone, per snow cone, and then we'll make 50 at the end. All right? Now, okay. So what we'll do now is, and this is handled differently by everybody. Uh, I like doing density this way. I know there's a formula for it, but I like paying attention to units of measure. What this means is 0.697 grams for every 1 cubic centimeter. Now, I like setting up a proportion because a lot of the problems in our course use proportions. So I'm just trying to be consistent, teach the students less, and be more efficient with methods. So I have a volume on the bottom, so I'm going to take this volume and also put it on the bottom. Now, paying attention to these units of measure have just basically told me where to put things. So I don't have to really think about it a lot. I don't have to guess whether I'm multiplying or dividing. It's going to take care of it for me. Now, this is unfortunately going to just give me grams, which is going to be a problem in a minute, but let's just go ahead and, so it's 1 times x. We'll get rid of the units of measure for just a minute. All right, we're going to let the calculator multiply this out. Okay, and let me just, okay, got that in my calculator now. And we're at 232.557 grams though. Okay, so we took the ice volume, right? And then we turned it into grams. All right, but that's no good because our cost is in kilograms. So let's convert that. There's a lot of ways to do this. Some, the science teacher probably just teach you to move the decimal 3 places, and that works. All right, I'm going to set up a proportion for that. I have 232.557 grams. I don't know how many kilograms that is. Now, how many grams to make up kilograms? Like, what's that ratio? Well, you got to know this. It's 1,000 grams to 1 kilogram. There are conversions in your conversion sheet. You could change, let's see, is there a grams? Yeah, I don't know if there's a grams to pounds. No, it doesn't look like it. No, I'm looking over at the formula sheet right now, and I don't see any other way other than to memorize this. Yeah. So you're pretty much stuck with that. You've got to know that 1,000 grams equals 1 kilogram. Okay. And hopefully we've done that by now. So we're going to cross multiply. 1,000x equals 232.557 times 1. So we're going to divide by 1,000. So this is basically where you just move the decimal place. In science, we would have told you move it back 3 places. You can let the calculator do it if you prefer, just to be certain. That's how many kilograms for every single. So that's kilograms for each cone, right? So 0.232557 kilograms for each cone. Now let's go get a cost for each cone. Okay, now that cost is back up here. A little tricky. It's $3.83 for every 1 kilogram, right? Well, how many kilograms did we have? 0.232557 kilograms. So we're going to get a cost. Let's see, we already used x, right? So let's use y. And again, we'll cross multiply, ignore. So let's ignore units of measure just for a minute. come back to them. All right, so each one, sorry, let me just type this in and multiply, what is it, 3.83. All right, I get about 89 cents per, 890693. That's each, okay? So now if we want 50 cones, it'll be 50 times 0.890693, okay? So hitting times 50 now, $44 and let's see, 53 cents. Now, some of my students asked me yesterday, which was pretty neat, how do you know which place to round to? And that's a great question. Money, it's implied that you're going to go, you know, in this country anyway, we go to the nearest cent, which is 2 decimal places once we're working with dollars. Unless they tell you otherwise, you've got to just know that. That's what we do. So, unfortunately, we got to think a little bit in terms of real life, and that's kind of how we determine that. So, there's the end of your August 2016 exam. Again, hopefully this site is helpful, and please subscribe, like a video, and good luck to you on the exam.